Hey everyone, welcome back for another deep dive.
Always fun to be back.
So this time we're tackling a paper about a new type of neural network architecture. It's called Titans.
Ah, yes. I've heard some buzz about this one.
Yeah, and it's all about this question of how AI can learn and remember information.
Especially over really long stretches of data.
Right, like when you've got just massive amounts of information to process. And you sent this one in, so it seems like you're really interested in like the cutting edge of AI.
Definitely. And how it could change the way we think about memory and learning. Even, beyond just AI itself.
Absolutely. Well, let's jump in, and luckily we have our expert here to help us unpack all the key insights of the paper.
Happy to help. It's a dense one, so buckle up.
Ah, will do.
Hmm.
So the paper starts off by talking about the limits of attention.
Right. That mechanism that's been like a game changer for AI, especially for natural language processing.
With transformers and all that.
Yeah.
But it sounds like attention alone isn't enough when you're dealing with truly massive amounts of data.
Yeah, it's great at understanding relationships within a specific window of data. But when you get to really long sequences, things start to break down.
Like trying to read a novel, but you can only see like a couple sentences at a time.
Exactly. You'd miss so much context and the bigger picture.
Totally. So the authors are basically saying we need to give AI a better memory if we want it to handle these larger scale problems.
Yeah, that's the core idea. They argue that we need different types of memory, just like humans do.
Oh, like short-term memory, long-term memory, working memory even.
Exactly. And that this is crucial for AI to understand and learn from these super long sequences of information.
It makes sense. We don't just rely on one type of memory, we've got a whole system.
And that's where Titans come in.
Oh, okay. So Titans are like this new family of AI models designed with different memory modules in mind.
Precisely. They've got three key hyperheads.
Hyperheads.
Yeah, it's their term. So you've got the core, the long-term memory, and then the persistent memory.
Okay, let's break those down. What's the core all about?
So the core is kind of like the central processing unit. It uses attention, similar to our short-term memory, to analyze the incoming data.
So it's like the AI's immediate workspace, where it's
Yeah.
actively making sense of things.
Exactly. Then you've got the long-term memory, which is a neural network that learns to store information over extended periods.
Hold on. How does an AI have long-term memory?
Well, they took inspiration from how humans form memories. You know how surprising events are more memorable?
Yeah, for sure. Like you're more likely to remember something unexpected.
Right. So this module is actually trained to prioritize storing information that's different from what it already knows.
Interesting. It's like a surprise metric that guides what's worth remembering.
Yeah, exactly. And it helps the AI focus on what's truly novel and informative.
Makes sense. So we've got the core for short-term, the long-term memory for like our experience bank. What about persistent memory?
Persistent memory is like the AI's foundation of knowledge, things that don't change.
Oh, okay. So it's not constantly learning and updating.
Not this part. So for example, if the AI is playing a game, persistent memory would hold the rules.
Gotcha. Or like if it's processing language, you would have the basic grammar rules.
Right. It's like knowing that water is wet or the sky is blue, just fundamental stuff.
Okay, I love how these different modules seem to mirror how our own brains work, but how do you train an AI to actually memorize things?
Well, it's a fascinating process. They use a combination of techniques.
Like,
Well, we talked about that surprise metric, but they also use a concept called momentum.
like the physics thing.
It's a similar idea. It helps the AI build up a memory of surprise over time, not just focusing on one weird thing.
So it's looking for like consistently surprising or unusual patterns.
Exactly. And then there's a forgetting mechanism.
Right, the AI can forget things.
Yeah, it has to prevent overload, just like our brains can't remember everything.
Makes sense. So it learns what's important to keep and what it can toss out.
Exactly. It's pretty sophisticated stuff. But there's something else that's really unique about how Titans learn.
What's that?
This memory training. It happens at test time.
At test time, meaning what exactly?
It means the AI is constantly learning and adapting its memory, even as it's encountering new information.
Wow. So it's like always on, always absorbing and updating. It's not
Yeah,
like,
it's way more dynamic and flexible than traditional models.
that's really cool. It's like lifelong learning, but for AI.
Exactly. They're not just trained on a fixed data set and then that's it.
So we've got these different memory modules working together. But the paper also mentions there are three distinct variants of Titans. They call them ME, MAG, and ML.
Yeah. And each one kind of offers a different way of using these memory modules.
Okay, I'm definitely intrigued. What makes each variant unique?
Well, let's start with MSC. It stands for Memory as a Context.
Okay, and what does that mean in practice?
So basically, it uses the long-term memory to provide context to the core.
So it's like the AI is using its past experiences to help it understand the current situation.
Exactly. It's all about connecting the dots between what it's seeing now and what it's learned before.
Makes sense. And what about MAG?
MAG stands for Gated Memory, and it focuses on flexibility, combining short-term and long-term memory through a gating mechanism.
A gate, like a mental switch.
Pretty much. It can control how much it relies on its short-term focus versus its broader knowledge.
So it's like you can switch between big picture thinking and detailed analysis depending on the task.
Exactly. And then you've got ML, which is memory as a layer.
Okay, and how's that one different?
MEL uses the long-term memory as like a pre-processing step, compressing information before it even reaches the core.
So it's like summarizing a long chapter before diving into the details.
Exactly. It's all about efficiency and streamlining the flow of information.
Okay, I see how each variant offers a different approach.
Yeah.
But the paper kept talking about deep memory modules. What do they mean by that?
Yeah, that's an important point. Deep memory modules are the ones with multiple layers, like a multi-story building.
And the more layers, the better.
Pretty much. Deeper memories are more effective at storing and retrieving information because they can capture more complex relationships.
Like our brains. It's not just a flat file cabinet. It's this whole network.
Exactly. But of course, there's a trade-off. Deeper memories take a bit longer to train.
There's always a trade-off.
Right, power versus efficiency. But they're still remarkably efficient, especially compared to other models like transformers.
So it's all about finding that sweet spot.
Exactly.
Okay, so far we've covered a lot of theoretical ground. But how do Titans actually perform compared to other AI models? Do they live up to the hype?
That is the million-dollar question. And luckily, the paper is packed with experiments.
Ooh, a real AI showdown. I love it. Tell me more.
Well, they tested them on all sorts of tasks, from language modeling to these really tough challenges called needle-in-a-haystack tasks, even stuff like understanding and predicting time series data.
Okay, we're going to need to unpack all of that. Let's start with language modeling. What is that exactly?
It's like a classic benchmark for AI. It's all about predicting the next word in a sequence.
So like the autocomplete on our phones, but way more advanced.
Way more advanced. And in these tests, Titans consistently outperformed other leading models.
Wow, really?
Yeah, they were really good at grasping these complex language patterns, even over really long passages.
Like super readers, basically.
Pretty much. And then there were those needle-in-a-haystack tasks.
What are those? They sound intense.
They are. It's where the AI has to find specific information buried in tons of data.
Like finding a single sentence in a library full of books.
Exactly. And guess what? Titans were amazing at these too.
No way.
Yeah, they consistently beat out other state-of-the-art models, showcasing those superior long-term memory capabilities.
I bet those memory modules play a big role there,
Yeah.
helping them quickly zero in on what matters.
Absolutely. It's not just brute force processing. It's like they develop a sense of what's important.
Okay, this is fascinating. But they didn't stop there, right? What about those time series tasks you mentioned? What does memory have to do with predicting the future?
Well, it turns out long-term dependencies are super important in time series data too.
So like understanding trends and patterns over time.
Exactly. And you know what? Titans were competitive with some of the most advanced models even in those tests.
This is wild. It seems like this concept of AI memory is applicable to so many fields.
It really does. And I think we're just scratching the surface.
This is blowing my mind. So we've got these Titans. They're built in a unique way. They learn differently. And they're already showing amazing results. What's next?
Well, let's dive back into those deep memory modules and take a closer look at the different variants of Titans. Then we can really start to understand how they're achieving these incredible results.
I'm ready. Let's go deeper.
So those deep memory modules, they're like the secret sauce.
Yeah, the paper kept saying how important they are, especially the ones with multiple layers.
Right, the deep ones.
Yeah, and it makes sense. Our brains aren't flat either. They're these complex networks.
Exactly. And the researchers found that these deeper memories, they're just better at storing and retrieving information.
Because they can capture more of those intricate connections.
Precisely. But of course, there's always a trade-off.
I was just thinking that more power probably means slower processing, right?
Well, they do take a bit longer to train, but they're still remarkably efficient, especially compared to some other models.
Like transformers.
Yeah, so it's all about finding that balance, power versus speed.
Right. But didn't they also test different types of titans? Like with different ways of using those memory modules?
Yes. They tested three main variants, MAC, MAG, and MAL.
And how do they do?
Well, they ran them through a bunch of different tasks,
Oh.
including some of those super tough, long context challenges.
From that Babylon benchmark.
Exactly. And what's interesting is there wasn't one clear winner across the board.
Oh, so a real AI battle royale.
Haha, pretty
Okay.
much. Each variant had its own strengths.
Okay, I'm on the edge of my seat. Give me the details.
All right, so for language modeling and some of those common sense reasoning tasks, MC and MAG were neck and neck.
Okay, so both pretty good at understanding language and basic logic.
Yeah. But then when it came to those really long sequences, where the AI had to remember stuff from way back, Make really pulled ahead.
Interesting. So MC is like the long-distance runner,
Yeah.
able to hold on to those long-term dependencies.
Exactly. Now, MAG was really good at tasks that needed more flexibility.
Because of that gating mechanism.
Right. It could easily switch between short-term and long-term memory, depending on what the task needed.
So MAG is like the multitasker of the group.
Yeah.
Adaptable to different situations.
Yeah, good way to put it. And then there's MAC.
Right. How did Mel do?
It was still powerful, but it had a bit lower accuracy compared to MAC and MAG.
So maybe its approach isn't quite as effective.
It seems like using long-term memory just for pre-processing might limit it a bit.
Like trying to cram a whole novel into a few bullet points. You lose some of the richness.
Exactly. Sometimes you need that deeper understanding of how everything connects.
So it really depends on what you're trying to do.
Yeah.
No one size fits all.
Exactly. And that's what's so cool about this research. It gives you a toolkit.
You pick the right tool for the job.
Precisely. And it's exciting to think about how this could be applied in the real world.
Yeah, for sure.
Yeah.
But speaking of real-world applications, the paper mentioned that Titans can be implemented in both PyTorch and JAIX. Why is that a big deal?
Oh, it's huge. Those are two of the most popular frameworks for machine learning.
So basically it means more people can use them.
Exactly. It makes it much easier for researchers and developers to build on this work.
Smart move. And speaking of building on this work, did they talk about any future directions for Titans research?
They did. They mentioned exploring even more sophisticated memory architectures.
Oh, wow. Like what?
Well, right now, they're using MLPs for the neural memory module.
Multi-layer perceptrons. Those are pretty standard.
Yeah, but they're thinking there might be even better ways to structure those memories.
Interesting. Like drawing inspiration from how our own brains work.
Exactly. Or even looking at other fields like cognitive science or computer architecture.
So much potential.
It feels like we're just scratching the surface of what AI memory could be.
It's both exciting and a bit overwhelming.
I know what you mean.
Yeah.
But it's a good kind of overwhelming.
Totally. So much to explore.
This whole deep dive into Titans has been mind-blowing. It feels like a whole new era for AI.
I agree. It's not just about recognizing patterns anymore. It's about true understanding.
And remembering and reasoning.
That's
It's a
right.
big step forward.
It makes you wonder what's next. What other breakthroughs are just around the corner?
I can't wait to find out.
Me either. And luckily, we'll be here to break it all down for you, our listeners.
Always a pleasure to dive into this stuff with you.
All right. Before we get lost in the future, let's wrap things up with some final thoughts for our listener. Okay, so we've covered a lot of ground here. Titans, memory modules, different variants, all those tests. What does it all mean for our listeners?
Right. Why should anyone care about these giant AI brains?
Exactly.
Well, for one thing, this research is hinting that AI might be on the verge of some seriously next-level understanding.
Like we're not just talking about pattern recognition anymore.
It's more than that. We're talking about systems that can truly grasp complex relationships, remember stuff over long periods, reason in ways we haven't seen before.
It's almost like we're giving AI the tools to think more like us, to see those bigger picture connections.
That's a great way to put it. And that's both exciting and a little bit, unnerving.
Totally. But think about the potential benefits here.
Oh, yeah. Imagine AI that can help us tackle climate change or develop new medical treatments, stuff that our human brains just aren't equipped for.
AI that can analyze data on a scale we can't even fathom.
Exactly. And uncover insights that would have been completely hidden from us.
That's powerful stuff. But it also makes you wonder, right? If AI can learn and remember like we do, could it also develop some of our less desirable traits?
That's a valid concern. Like, could it become biased or even manipulative? It's crucial that we develop these technologies responsibly. Think about the ethics every step of the way.
It's not enough to just make powerful AI. We have to make sure it's aligned with our values.
100%. And I think this paper, with its emphasis on memory and understanding, is a step in the right direction towards AI systems that are not just powerful, but also more
They're
transparent.
more explainable.
Exactly. So we can understand how they're making decisions.
That's a good feeling. It means we're not just passengers on this AI train. We're the conductors.
We get to choose the destination.
I like that analogy.
Uh,
So
and
it's not about AI versus humans. It's more like AI with humans.
Working together to solve problems that we could never solve alone.
This whole conversation has been incredibly thought-provoking. I feel like I have a new appreciation for what AI is capable of.
Me too. And this is just the beginning. Who knows what's next?
Right, the field is moving so fast.
It's a really exciting time to be following AI.
Absolutely. But for now, we're going to have to wrap things up. Big thanks to you, our expert, for breaking down all this complex research.
Always a pleasure.
And to our listeners, thank you for joining us on this incredible deep dive into the world of Titans and AI memory. It's a wild ride, and we can't wait to see what the future holds. Stay tuned.